This is the second half of the practice test. Hopefully I can do this in under 15 minutes. Number 7. You have a 6-sided die and it's being tossed twice. We want the following probabilities. Think independence. What I'm saying here is if you think about this problem, when you toss the die first, it really has nothing to do with tossing the die second. They're independent events, so just keep that in mind. I want the probability I get a 2 on the first toss. Well, when I toss the die, the first time I toss the die, there's one way to get a 2. There's 6 things that could happen. Simple probability definition, right? B, the probability I get a 3 on the first toss and a 3 on the second toss. Well, I need the probability of 3 on the first toss and 3 on the second toss. That's how I'm going to denote that. Well, that's where independence comes into play. Since these two things are independent, that's just the probability of a 3 on the first toss times the probability of a 3 on the second toss. Well, the number of ways you can get 3 on the first, one way. The number of ways something can happen, 6 ways. The number of ways you can get a 3 on the second toss, one way. The number of things that can happen on the second toss is 6. It's multiplication. 1 times 1 is 1. 6 times 6 is 36. So the probability is 1 over 36. What's the probability I get a 4? The probability I get a 4 is a 4 first or 4 second, right? Doesn't matter when I get it. So this is the probability of a 4 first or 4 second, which is the probability of 4 first plus the probability of 4 second minus the probability of 4 first and 4 second, right? Well, 4 first is 1 out of 6. 4 second is 1 out of 6, right? Think about it. Minus, well, just like in B, if you think about it, this is going to be 1 over 36 in itself. So you have 6 over 36 plus 6 over 36 minus 1 over 36, which is 11 over 36. So that's your answer. Okay? Moving on to number 8. Remember, you can always stop the video, right? A bag contains 4 Rex, 3 Hermes, and 2 Toast doubloons. 2 doubloons are selected without putting them back. So I pick a doubloon, put it on the side. Pick a doubloon, put it on the side. I want the probability I get a Rex first and a Hermes second. So what I'm saying here is, what's the probability that I get Rex first and Hermes second? Well, we have a formula for and. That's the probability of Rex first times the probability of Hermes second, given Rex was first, right? There's your and formula, right? Rex first times Hermes second, given Rex first, right? So, the probability of Rex first, there are 4 ways to get Rex. There are 7, 8, 9. I'll make sure I count right this time. 7, 8, 9 ways to get anything, right? Now for the second part, we're going to stop here because this is a conditional probability. I'm telling you I have a Rex first. I did not put the doubloon back. So my world here looks like this. 3 Rex, 3 Hermes, and 2 Toth. Remember, when you have a conditional probability, what you have to tell yourself, what has changed? Well, I had a Rex first. I didn't put it back. So there's 1 less Rex doubloon. So now, how many ways can I pick a Hermes in this world? 3 ways. How many ways can I pick something in this world? 8. Do your math. It's 12 over 72, but you can reduce it to lowest terms, but I said on my test that's okay. All right? You don't have to do it because it's not a remedial math course. I want to just know you know how to calculate probability. Second one, find the probability of getting a tooth given the first one was not a tooth. I want the probability I get a tooth. Well, that's tooth second because I'm talking about the first one not being a tooth. So getting a tooth has to occur on the second toss, right? Given it was not tooth on the first toss, right? Well, now think about it. It really doesn't matter if it was a Rex or Hermes, right? All I know is that there's one less of them, right? So we know that when it comes to select the second one, there are 2 tooth doubloons. There are 6 other doubloons, right? Because either the Rex or the Hermes is missing. It really don't matter to me. Well, the number of ways I can get a tooth in this world is 2. The number of ways I can get anything in this world is 8. So 2 out of 8. So a little tricky, this one, right? It wasn't hard, but you just had to think about it. The first one's not tooth. So you know there's two tooth doubloons. But something's gone. So you had 9 doubloons. You got 1 less because it's the second selection. So the number of ways to do something in the new world here is 8. Moving on to number 9. We have a little survey going on here. I'll let you kind of read it over. You can stop the video, look at it, right? Okay, so I want the probability an employee does not smoke. Okay, an employee does not smoke. The number of people that do not smoke is 50. The total number of people in the survey is 89. So that's the probability somebody doesn't smoke. The probability an employee does not smoke given they're not a high school graduate. So they're not a high school graduate. So again, that's what we know. So what we're saying is that our world now consists of this right here. Here's our world now because they are not a high school graduate. In this world here, how many people do not smoke? 7 plus 25. In this world here, how many people are there? 44 plus 21. So 32 divided by 65. 32 divided by 65, right? And did I mess up here? Let me see. Let me stop my little video right quick here and check. All right, I'm just having a bad night, but that's why we have an eraser, right? Oh boy. Well, again, I told you this is unedited, and I also told you that you're watching this thing at your own risk. Okay? I'm live here at UNO. So, anyway, I need to read the problem. The employee is not a high school graduate. This is my world here. I'm not a high school graduate, right? Okay. Not a high school graduate. That's the condition, right? How many do not smoke in this world? 18. How many people are in the world? 24. A lot easier than what I said, huh? All right, let's move on. The big and final problem. We can do this in under 16 minutes, I bet. Here's a big problem, always on the final exam. A newspaper advertises 7 different movies. 7 different moves, huh? Well, I caught that mistake. That's movies. Okay. 5 different plays. So we have 7 different movies. And we have 5 different plays. The couple chooses 3 activities to do. So we're going to pick 3 activities. And I want the probability that they go to 1 movie and 2 plays. I want the probability they see 1 movie and they see 2 plays. Okay? So, Basic definition of probability is right here. The number of ways we can pick one movie, two plays, divided by number of ways pick three things. That's the definition of probability. If you can count your way through it, count your way through it. I need to pick one movie, two plays. How many ways can I do this? I need to pick three things. How many ways can I do it, right? So, let's look at the numerator. I need a movie. I need two plays. Oh, sorry. I need one movie. I need two plays, right? The movie's got to come from 7 movies. The plays have to come from the 5 plays, right? All right? Now, when I pick the movie, there's 7 ways. When I pick the play, there's 5, but then drops down to 4. Need to see 2 plays. Okay? So I have 7, 5, 4. Is there order here? For the movies, there's no order. I picked one movie. For the play, there's no order. So I have to divide by 2 times 1, 2 factorial. When you do your math, you're going to get 70. So now I know my numerator here is 70. What about the denominator? Well, let's erase this stuff. For the denominator, I need 3 things I'm going to do, right? Activity 1, activity 2, and activity 3. Doesn't matter. I didn't say there was any particular combination, right? Okay, the couple selects 3 activities to do. I'm asking for the probability they end up picking one movie, 2 plays, right? So, for the denominator, when I pick an activity, it comes from 12 things because I'm not distinguishing between movies and plays now, right? When I pick the first activity, there's 12 choices. I go for the second one, I can't put it back, 11. I got to do 3 activities. Then 10. So 12, 11, 10. Do I have order? No, there's no order. So I pick 3 things. So 3, 2, 1. Do your math and you get 220. So here's the probability, 70 over 220. I suggest you watch this video again because you will see a problem on your test and you will see a problem like this on the final exam. It's not a bad problem. You just have to realize that the numerator is the ways you can pick one movie and 2 plays. And when I do that, I'm distinguished between movies and plays. But when I look at the denominator, I just need 3 activities. I don't distinguish between the 3 activities, so there's a total of 12 to pick from. And then the hardest part might be to realize there's really no order here, okay? And if the couple goes and sees Dr. Zhivago or Cats, and then goes and sees the Muppets movie, right? They won't necessarily say them in order, right? Don't matter, they've done all 3. Who knows? But anyway, there you go. That's problem number 11, and that is the practice test. All right, so good luck with everything. Again, sorry about the little mistakes here. At least I caught them. I think I caught them all, right? You can always go back and rewind the video or ask me questions in class. All right, well, thank you very much, and signing off from my old alumni, UNO. At least I think I'm signing off. Got to get used to things here. All right, we're going to sign off.